Okay, so question 2, the exam, practice exam 2, 154, and this is fall 2013. Okay, so this is a question of Fermat's little theorem question, right, Theodore? Okay, so this guy has to be prime, and it is, otherwise the problem won't work. And whatever this happens to be is 5. It could be anything, but by Fermat's little theorem, which you can abbreviate, 5 to the power of, let's say prime is p, you do p minus 1. So p here is 11, so you put a 10 here because it's 1 less than this number 11 over here is equal to 1 mod 11. And we just know it. We don't have to prove it. If you want to, for fun, you can go ahead and show that this is true. But this is a theorem that you just use. Okay, now what you do next is you say, well, if 5 to the 10 is equal to 1, then it implies that, for example, 5 to the 1,000 also equals 1. So 5 to the 1,003 is 5 to the 1,000 times 5 cubed. And then this piece cancels out because it's just 1. All right? So the way we officially do this is we say, we say 1,003 mod 10 equals 3. And how do we do that on our calculator? Obviously this is an easy problem because it's just mod 10. But let's just go through the process in case it's not that easy. So you go 1,003 divided by 10, right? And then there's some integer you got to get rid of, the integer part that we don't care about. So this is our remainder, but it's expressed as a decimal. Multiply by 10, that's our modular system. And it gives us this 3 that we have down here. Okay, so that's the process. All right, so now what do? We're halfway done. So this would be worth about half credit if you stop there on the exam. Then you say 5 cubed mod 11 is equal to what? This is not too bad. 125 mod 11. Now, because 11 squared is 121, and we happen to know that, this is really easy. This must be equal to 4. So this is actually equal to 4. The answer to this problem is actually 4. But let's say we didn't recognize that. I mean, in the answer key, I assume you recognize that. But let's say you didn't. So you pull out the calculator, and you say 125 divide by 11. Okay. Subtract out that integer, 11. Now, this is your remainder as expressed as a decimal. So you multiply by 11 to bring you back to an integer. So you say 4 mod 11. 5 to the 1,003 is equal to 4 mod 11. Okay, that's a little bit crooked. Sorry about that. There we go. That's a little neater. Okay, so hopefully that helps you understand this problem a little better.